The following video shows some of what went on in a 9th grade inner city classroom in Hartford, Connecticut. While learning the concept of electrical resistance using the Castle curriculum revised version of Section 2, called What Do Bulbs Do to Moving Charge? Previous knowledge included being able to describe a circuit as a complete conducting loop along which charge flows. Students had already had the experience of placing a compass under wires and completing the circuit to observe needle deflection in every wire. It was observed that the amount of compass deflection and therefore the flow rate was the same in every wire in the circuit. Instead of beginning the section on resistance with one resistor and then two resistors in the circuit to show that charge flow rate is reduced but not the amount, we started with just a wire. This was part of the revision of Section 2. Students were surprised.
Oh no, is this one?
The way you guys came into class today.
Ooh, counterclockwise. What's counterclockwise? Look. See that?
Yeah.
It went fast to like crazy charge. Alright, so that's what it does. Write that down.
Because now what we're going to do is ask you to draw arrow tails next to this wire. Okay, with this circuit connected, how many arrow tails would you draw?
1, 2, 3. No, I don't know.
Well, what did the compass needle do?
Like 3.
It moved.
How far?
A lot.
Oh wait.
5, 1, 1. It's the greatest.
Have you ever seen it move that far?
No.
No. So, how many arrow tails?
5. The
All right.
greatest. It's the
2,
greatest.
3, 4, 5. Boom. And it's got to be pointing in that direction, right? Because that's away from the positive toward the negative. Okay? Now, here's the next question. How does the wire, just a wire, affect charge flow?
I don't know if there's like something inside the wire or something that just makes it go straight. Like, because the wire only goes straight, so I guess the charge has to go straight through.
Like, I think that there's so much charge over it and it was stuck in the wire, it didn't have anywhere to go because usually it would go to the light bulb. So it probably was just like trying to find somewhere to go and it like kind of like bounced everywhere.
Take the energy out of the battery and bring it to the compass.
It transports the current.
It transports
The current from one end of it to the other.
Okay, the question is about charge.
Yeah, the current is the flow of the charge.
Well, the current is another name for
Flow of charge.
the rate of charge flow.
Oh yes, rate.
So it transports the charge, you're saying.
Yes. It
But
transports.
that's the stuff that's moving through the wire, right?
Uh-huh.
Lewis?
Is it like the wire like the wait I know this. The conductor of the charge.
Okay. So wire just conducts the charge,
Yeah.
you're saying.
I guess.
Yeah.
Okay, does it use it? Lauren?
I think that the wire, like what Mia said, kind of sort of transports the charge from the negative side to the positive side. From the plus to the minus.
In the next activity, carbon resistors covered with masking tape disguised as mystery devices were added to the circuit to observe the effect on compass needle deflection. Bulbs were added to the circuit in place of mystery devices. Okay?
Use the round ones, right?
And let's do 2 cells, just for safety so we don't burn this one bulb out. Okay? So you got your compass? You need a compass, your kit, and you're good to go. Right, 1, and then 2, and then 4. Connect them all up.
Yeah.
2 cells.
Wait, don't we have to put the positive in
Wait, put it over again.
This is 2 cells in 1 bulb. Does anybody want to volunteer a definitive statement on the question, how do mystery devices act like bulbs? Raphael?
Well, the same as light bulbs, the mystery devices, the less mystery devices, the faster the flow rate is, and the more mystery devices, the slower the flow rate is. Bulbs use the flow rate and
Bulbs what?
use the flow rate like
They do?
to light it up.
They do?
Well, the energy and
Oh,
mystery
you said
devices-
light up.
Yeah, to light up.
Okay, so bulbs light up and mystery devices
Don't.
don't.
But they still slow down the flow rate the same way.
When we did this circuit here, first thing, and we put the compass under here, and under here, what did we find?
That when the compass was in the first place where your hand is right now, that the compass needle moved more than when it was down by the Unless I'm wrong, but I think I'm right.
Okay. Time out. Check.
He's a junior. He's in my class.
No mystery devices. Take those off. Check
got
the
it.
previous experiment.
Distance was the same, and they all move the same way, and the distance, which will move like 3 spaces or 4 spaces.
Any other groups agree with that? How many other groups agree with that? 1, 2, 3, 4, 5. And you guys are almost.
Yeah.
Okay. What's your evidence?
That charge stays the same in all of them, and it gets used up.
Which way does charge go?
That way.
No.
The other way.
Up.
From
positive to negative.
Okay, goes this way. True?
Yes.
All right. Now, if it gets used up in this bulb, and then a little more gets used up in this bulb, what do you expect the compass needle deflection in this compass to be?
Not that much.
Not that much.
Like one move, I'm going there a little bit.
Well, is that what you saw?
A little bit.
Really?
Was the compass needle deflection the same in all 3 wires?
No.
No.
Yeah.
No.
Yes, 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 yes,
And we say no.
yes, yes.
We say no.
We got you.
Yours was almost the same. $1 million question. What does adding a third bulb in parallel do to the overall resistance in the circuit? One, both sides. So you're going to go around the bulb. So you want to keep doing it. You can keep repeating the experiment and just hook up one wire, and then just keep touching it.
They're bright nerds. Oh, Willie. They're bright nerds. So, because these two lit and this one did not light, what does that mean?
It barely moves.
What did we learn? What does adding a third bulb in parallel do to the overall resistance in the circuit? So what do you think it does?
The flow rate goes up when you add the third bulb. It's not enough current for all 3 bulbs, so the resistance is too much resistance for those 2 bulbs.
Well, wait a second. The flow rate goes up for the whole circuit?
Only one, like how I predicted that the separate bulb was going to be the only one lighting, I was right.
Like maybe it's like it lowers for the 2 bulbs, and then like once it goes to the other bulb, it gets higher.
So that's the same as this.
This Bria said that it's too much resistance to go through all 3 bulbs because they like 100 watt each.
So are you saying that adding a third bulb to a circuit increases the resistance?
Yes.
So you have this connected with the compass needle under the wire,
Yeah.
right? So the compass needle was like maybe like that, right? Okay. Then you added this. Did this go that way a little, or that way a little, or not, or nowhere?
Nowhere.
I don't think you did it.
No, it went that way.
I didn't see anybody do it.
It went that.
Can it go this way a little bit more?
No, the other way.
That way. Went back a little more.
It went back.
I got some groups saying it didn't move at all. Some said it went backwards. Some don't know. Some are sitting there looking at me like I'm from Mars.
It went up 3 more. And then as we kept putting bulbs, it kept going up 3 more.
Okay.
So the flow rate increases.
The more bulbs you add onto one bulb, it increases the
greater
flow
the-
rate. Yeah, the greater the flow rate is. To parallel
In parallel.
bulbs. Yeah.
Model building and constructing learning are not easy. Many students are used to being given information, memorizing it, and then repeating it back on a test. Hands-on learning also needs to be minds-on. Students must be active learners, and teachers must ask the right questions. Delivering instruction in a way that requires students to respond to questions, to share their thinking, and test their predictions results in the most meaningful learning and conceptual understanding. We as educators need to realize that this is all part of an ongoing process to find the most effective instruction.
I can't believe it.